Hey pre-calc students, welcome to our lesson for today of finding all possible rational zeros and all real zeros. So there is a chance that you will take a math class in the future that requires you to find all the real zeros of a polynomial without the use of a graphing calculator. If that is the case, then there is a formula essentially that you could use to find all the possible zeros, and then what you would do is you would check each and every single one of those possibilities until you find the ones that work. So the possible rational zeros. So in this class, we're going to ask you to find the possible rational zeros. Those are all the possibilities of where your polynomial can touch the x-axis. Now the formula is that you take all the factors, positive and negative, notice the plus or minus, all the factors of the coefficient of the constant term. So that's important. You take all the factors of the constant term and you put them you write them as a ratio or fraction of all the factors of the coefficient of the term with the highest degree. Okay, so the term with the highest degree goes in the denominator, all of those factors, and again, you're doing both the positives and the negatives. So for this class, we're going to ask you to find the possible rational zeros and list them, but just remember, no repeats. Okay, we're going to ask you when you make your list, do not list any repeat numbers or ratios. All right, take a minute to read the directions for 1 and 2. Notice that they're not asking you to find all the real zeros, as in the previous lesson that we've learned. They're not asking you to find all the real zeros. They're asking you to find all the possible, rational. So remember, the word rational is another word for fractional. Okay, zero. So rational numbers are any number that can be written as a fraction. Now, you have to do this without using a calculator, okay? Without any calculator. So what we would do is we would create a ratio. So remember, a ratio is a fraction. So create a ratio of the positive and the negative factors of the constant term. So your constant term would be your 16. So what numbers are the factors of 16? All the numbers that multiply to 16. Well, there's 1 and 16, 2 and 8, and then 4 times 4. If it's easier for you to do it this way with a little T-chart, 1 and 16, 2 and 8, 4 and 4, go for it. And I'm going to put those over the plus and minus factors of the coefficient of the term with the highest degree. So the highest degree here was cubic, and the coefficient was 1. So all the numbers that multiply together to get 1 are just plus and minus 1. Now what you have to do is you have to take each and every one of these numerators and divide them by the denominator. Always make sure that you reduce your answers. So we've got 1 over 1, which is 1. But remember, because of the plus or minus, we have to consider the fact that the answer could be 1 or negative 1, no matter whether I use a positive 1 on the top, positive on the bottom, negative on the top, negative on the bottom, or if they're opposites, negative on top, positive on bottom, positive on top, negative on bottom. Sounds kind of complicated, right? Okay, then I'm going to take the next numerator of 2 and divide it by 1. Reduce it, 4 divided by 1. Reduce it, 8 divided by 1. Reduce it, and 16 divided by 1. But again, you're considering the fact that each of those could be plus or minus. So maybe I should have put a little colon here, so that anything after that plus or minus, you know that any of those numbers could be positive or negative. So you should have 5 pairs of possible zeros. So it is possible that this polynomial touches the x-axis at 1 or negative 1, 2 or negative 2, 4 or negative 4, 8 or negative 8, and 16 or negative 16. And that's it, kids. That's all the question is asking. What are the possible rational zeros? Where is it possible that the polynomial can touch the x-axis? Okay, and remember, we're talking about rational zeros, so this does not include irrational zeros, the ones that have those imperfect roots. Okay, so again, for the formula, you're going to create a ratio of all the factors of your constant term, so all the numbers that multiply together to get 8, 1 and 8, 2 and 4, and that's it. Remember, if you would like, you can also do a table of value, or a t-chart, to list the factors. And then you're going to list all of the factors of the coefficient that's with the linear term, or sorry, with the leading term, the highest degree. So we've got all the factors of 2 are 1 and 2, and that's it. So now we have to take every numerator and divide it by each one of the denominators. So we're going to take turns. We're going to take 1 and divide it by 1, 2 divided by 1, 4 divided by 1, and 8 divided by 1. All of those are going to come out exactly the same, right? 1 divided by 1, 2 divided by 1, 4 divided by 1. You get the idea. But now we have to take each of those numerators and divide them by the 2. So now 1 divided by 2 is 1/2. 2 divided by 2 is 1, but I'm not going to list it because, okay, just so you know, we don't list it because it's already listed on our list. So no repeats. And then 4 divided by 2 is 2. That's already on the list. So remember, we already had those. And then 8 divided by 2 is 4, and that's already on the list. So then we are done listing all of the possible rational zeros. So be prepared if you're ever asked to make a list of all the possible rational zeros of a polynomial. That's what you're going to have to do. You're going to take the factors of the constant term and divide them by the factors of the coefficient of the highest degree. Okay, now, so far in the previous lessons, we've always given you a 0 to start working with, okay? But now it is your job to use your graphing calculator to find at least one 0 to begin the process yourself of solving the problem algebraically. So we are no longer going to say, hey, use this 0 to find the rest of the zeros. Nope. You have 3 choices to find the 0 on your own. You can look for the x-intercepts on the table in your graphing calculator. So for this, you would push second. So the second button, and then graph. That will take you to the table. Now, any ordered pair that has a value for x and a 0 for y is an x-intercept and thus a 0. You can also use second trace and use the 0 option, which is usually option 2. Let me double check. Yep. So you can select that. That's option 2. Select option number 2. And we've done that before when we were solving complicated equations. Now, you might have forgotten, so I'm going to show you again. And then your previous advanced algebra teachers might have taught you that you can also use an app like PolySMLT to find a solution. It's an app that you download to your graphing calculator that tells you what the solutions or zeros are. So quick reminder that x-intercepts, zeros, and solution are essentially the same thing. It's just how you write their answer that matters. Okay, so an x-intercept, you write it as an ordered pair. A 0 and a solution, both of these are written as x equals a number. Okay, so what I would like you to do is go ahead and access your graphing calculator. You can use the one in your Chromebook if you have the app there too, and type f of x into your y equals. So we're going to go ahead and try finding the zeros in using different strategies, using the intercepts, using the zeros, or using poly-SMLT. I'll show you all the different ways, and then from there you can pick which one is your favorite. Okay, so right now you should be typing in your f of x equation for number 3, the x cubed minus 4x squared minus 4x plus 16 into your graphing calculator. Okay, so once you have it in your graphing calculator, I already pre-entered all the equations we're going to use on the notes. So give me 1 second so I can deactivate the ones for the other problems. Okay, so right now you should just have your x cubed minus 4x squared minus 4x plus 16. Now let's just do a quick graph and see what this thing looks like. Right now, my window is from negative 10 to positive 10 in both directions on the x-axis and y-axis. Remember that if you'd like, you can adjust your window. So if you want to go a little bit higher, you can select the window button. You can also use zoom standard to just go back to the regular positive 10 and negative 10 window. Now, I can tell from this graph that the cubic intersects the x-axis. It looks like, I'm not sure, but it looks like it intersects at negative 2, positive 2, and positive 4. Now you want to be careful because you don't want to just eyeball it. You want to be 100% sure. So it looks like the first one is negative 2. To double check that for this problem, I'm going to use my table. So I'm going to go to second graph. And if negative 2, look at that, negative 2 comma 0 is on my table, then that means that it is an x-intercept, and it is in fact a 0. Look at the other ones. 2 comma 0 is also an x-intercept, aka a 0 or solution, and so is 4, 0. But you don't want to just by eyeballing it say, oh, yeah, it hits the x-axis here. You want to double check for sure using your table or one of the other strategies that I'm going to show you later. Now, I'm going to go back to my graph, and remember that you are allowed to choose any one of these zeros to begin your process of finding the rest of the zeros. Okay, so I tend to go from left to right, so I'm going to go ahead and just choose the negative 2 to begin my solving process. Okay, so again, I used my table to find 1 0, and that's what the directions say. Use your calculator to find 1 0, and then use that 0 algebraically to find the rest of the zeros. Since my 0 was negative 2, that's a nice, clean, rational number. I'm going to go ahead and use synthetic division to break down this cubic into a quadratic. So I'm going to go ahead and, for synthetic, you want to use just the coefficients. Could you have used long division? Absolutely. You just would need to use x plus 2 as your divisor. Okay, so bring down the first column, multiply, add, multiply, add, and then multiply. Guess what? Your remainder should be 0. How come? Well, because I looked at my graphing calculator and I saw that it was a 0, negative 2 comma 0. Okay, so again, we saw on the calculator that negative 2, 0 was an x-intercept, which led us to believe that x equals negative 2 was a 0. Okay, so we started with a cubic, now I have a quadratic. Quadratics, so again, remember the directions. It said use your 0 to find the remainder of the zeros, and we started with a cubic, now I have a quadratic. I'm going to try to see if I could factor this. In case you're not sure if this is factorable, you can use the discriminant b squared minus 4ac. Okay. And you should get an answer of 4. 36 minus 32. That means you can factor this. If it was not factorable, then you would use the quadratic formula to solve. So I'm going to factor this into x minus 2 and x minus 4. Then I'm going to set each of those linear factors equal to 0. And look, remember our graph for this cubic. It intersected the x-axis at -2, +2, and +4. And those are my answers. I'm going to go ahead and put them in order from smallest to biggest. Okay, when you're ready, go ahead and type number 4 into your graphing calculator. You're always more than welcome to use the table. Just be aware that sometimes the zeros are fractions and fractions don't pop up on the table. Okay. So now I'm going to go ahead and focus on that next cubic, and I'm going to graph it. Okay. So notice that when I graph it, the first zero on the left is between the -1 and the -2. If you don't like working with fractions, then let's maybe not use that one. Pick any of the other zeros. It looks like this cubic intersects the x-axis at 2 and 3. So you could pick either the 2 or the 3. Now, let's say all of these were fractions. They all didn't intersect at an exact whole number. Then the table wouldn't help me because the table only counts by integers, the whole numbers, okay? Positive and negative. So another option is second trace. If you select the option that says 0, now right now your cursor is at 0, 0. If you want to find the 0 on the left, you would have to click once below or to the left of that 0 and then to the right of it. So below and then above. But that one's a decimal, looks like, so I'm going to go ahead and pick. So right now, look at the bottom. It says x is at 0.3. So I want to get, I think that's a 2. So I'm going to get closer to that. Slowly but surely. Okay, now I'm at 1. There it is. Keep going. I'm getting closer. Okay, so I'm going to click one time before it hits the x-axis and one time after. So you want to click to the left of that 0 and then to the right. So it's going to say, what's the left side? So you're going to click once, enter, and your arrow should be pointing to the right. So now you have to move to the right and just click once or twice so you get past where the 0 hit the x-axis, select enter again, and you've now marked this almost like really skinny rectangular area. You see how the arrows are pointing towards each other up here at the top. So you're telling them that the 0 is between those two values. So it's going to say, do you want me to guess? You're going to say, yes, sir. Yes, ma'am. Okay, so that confirms that 2, 0 is a 0. Again, this would appear on the table because your table counts by integers. Right, so there it is, 2, 0, and 3, 0. If they had all been decimals, then none of them would pop up on the table, which is why I want you to be able to find the zeros using second trace. Okay, so we just confirmed that 2 is a 0. I'm going to go ahead and set up my synthetic division. Remember, synthetic division allows you to use any rational zeros. You found that 2 is a rational 0. So now I'm going to go ahead and follow the process of synthetic division. Multiply and add, multiply and add. And guess what, kids? What should your last column be? A remainder of 0. because, as you saw on the graph, 2, 0 is an x-intercept, which means x equals 2 is a 0. That means it divides perfectly and evenly into the polynomial. All right, so I'm going to go ahead and solve this quadratic. You can check to see if it's factorable. So you can use the discriminant, or you can just ask yourself, are there numbers that multiply to negative 45 that add to negative 4? So take a minute and either use the discriminant This is factorable. So if you didn't get a discriminant that was perfect, double check it again. You want to make sure you have negative 4 in parentheses before you square it. Now, if you don't want to factor it, you can use quadratic formula, but this discriminant is 196, and the square root of 196 is 14, okay? So that means you can factor it. Okay, so pause the video for a second and factor it yourself if you haven't done so already, or use the quadratic formula to find the rest of the zeros. Press play when you're ready. Okay, hopefully you did not cheat and you got answers of negative 5/3 and positive 3, and don't forget to also include the original 0 that was given to you. Now negative 5/3, okay, so negative 5/3 is negative 1.66666666, repeating. Okay, now if you still have your function graphed in your graphing calculator, you can go back and you can see that negative 1.666 is very possibly, well, it is the 0 that was most to the left, that we knew wasn't exactly negative 1 or negative 2. That's negative 1.66666, aka negative 5/3. The next two examples have higher degrees, so we are going to allow you to use your graphing calculator more than once to find two zeros, and then from there do algebra. So essentially you're trying to get to a point where you can use either quadratic formula or factoring. Okay, you want to get it to a quadratic. All right, so go ahead and type in number 5 into your graphing calculator. For this one, I'm going to show you how to use the app PolySMLT to find a solution or a 0. So go ahead and type it in. Pause the video and push play when you're ready and you've got it typed in. Okay, so this is a quartic equation, a quartic polynomial. It has a maximum of 4 zeros, and it looks like it does intersect the x-axis 4 times. Now, it might not be clear where it intersects the x-axis, so again, if none of these are whole numbers, so using a table would not be a good choice. If I wanted to, I can use second trace and use the zeros by clicking to the left of a 0 and then to the right of the 0 and having the calculator guess the intersection or from the polynomial to the x-axis. Or you can go to apps. The apps button is next to the math button. Go to apps. Now, not every calculator is going to have this, so this is only an option for those of you that have the PolySMLT app. Okay, now you might have the PolySMLT or PLYSMLT2. So mine is option number 7. Now what I want to do is I want to find the roots, aka the zeros. So I'm going to go to Polynomial Root Finder. So option 1. And it's asking you, what is the order? What's the highest degree of your polynomial? Mine is a quartic, so I'm going to select the 4 by just hopping over with my arrows and pushing enter. Don't worry about everything else. And then your screen is not a touch screen, so you can't just, click on next. The next button is, to go to the next, you're going to select graph. So the button that you're going to push to go next is graph. So on your actual graphing calculator, you're going to push the button that says graph, and you're going to type in the coefficients. So notice it's asking you A4, A3, A2, A1, A0. So these are the coefficients. Your quartic had a coefficient with the quartic, or x to the 4th, of 4. Your cubic had a negative 12 in front. Your quadratic had a negative 55. Your linear had a positive 6. And your constant term was a 15. To solve, you're going to also push the button that says graph. Now notice that 2 of these answers are funky decimals, which means that they're irrational. But there are 2 decimals that are short and sweet. So you are allowed to pick any of these nicer numbers, because these nicer decimals can be written as rational numbers. The other ones cannot. So non-repeating decimals are irrational zeros. You don't want to use those. So either pick negative 2.5 or negative 0.5 as your starting zero. I'm going to go ahead and pick negative 2.5. But again, when you're taking your test or quiz, you get to pick. So if negative 2.5 is a 0, then if I want to use synthetic division, I can leave it like that, or I can write it as negative 5 halves. Okay, those are the same. You pick. You can leave it as a decimal. I also noticed that negative 1/2 was a 0. And again, you can leave it as a decimal, or you can change it to a fraction. So remember, the directions are allowing us to find 2 zeros. Okay, I'm going to set up my synthetic division. You can use negative 2.5 if you want. Oops. Set up my coefficients. Remember, synthetic division is always a good place to start if you have rational zeros. Rational zeros can be written as fractions. Negative 2.5 can very easily be written as negative 5/2. Okay, so negative 5/5 times 4 is negative 10. Then add. You might want to pause the video and try this part yourselves and then push play and see if you did it right, because I don't want you guys to just write down what I write. You need to be practicing on your own. So maybe pause the video right now and continue on with the synthetic division, and then push play to see if you are correct. Now your last column should be a remainder, since we knew that negative 5 halves, or negative 2.5, was a 0. Now we started with a quartic, right? So now this guy is a cubic, since we took out a linear factor. Notice that it's missing the linear term. Okay, we still need to solve it. So I am now allowed to use my next zero. So I can use my next zero of negative 1/2 with those coefficients of 4, negative 22, 0, and 6. Remember, when you're doing synthetic and long division, if you're missing any of the terms, you got to fill them in with a 0. Okay, so again, remember that we were allowed to find 2 zeros on our graphing calculator, so I'm doing synthetic twice, and then I'm going to be left with a quadratic that I can either solve by factoring or with the quadratic formula. Okay, pause the video now, continue on with your synthetic division, and then push play when you're ready. Okay, so now that I'm left with a quadratic, before I check to see if I could factor it or if I could use the quadratic formula, I notice right away that there's a GCF here of 4. So I'm going to go ahead and take out that 4 and divide it out. It doesn't actually disappear. It's still there, just out in front as multiplication. Now, this cannot factor. There are no factors of 3 that add to -6, so I'm going to go ahead and set up my quadratic formula for it. The discriminant for this problem, b squared minus 4ac, is 24. And when you break down 24, it's 2 root 6. Now, when you are solving by factoring or solving by the quadratic formula, you're supposed to set all your factors equal to 0, okay? Now this guy, there's no point in setting that one equal to 0 because there's no variable on the 4. 4 doesn't equal 0, so that doesn't make sense. A GCF of just a number does not affect the solutions, the zeros. Okay, x equals the opposite of b plus or minus the square root of b squared minus 4ac, which we said was 24, all over 2 times a. Simplify. And you get 3 plus or minus root 6. So the complete list from smallest to biggest, left to right, it's okay if you keep your conjugates together, is -5/2, -1/2, and then your 2 conjugates. If you're going to split up your conjugates, make sure that you put them in correct order. So if you're going to write 3 minus root 6 and then 3 plus root 6, make sure you put the 3 minus root 6 first because it's smaller than 3 plus root 6. Okay? All right, so does it matter which 0 you start with? No. You always get to choose which 0 you start your synthetic division with. So take a minute to type in that last equation into your graphing calculator. Pause the video right now and then push play when you're ready. Okay, so the last problem is a quintic. It has the potential of intersecting the x-axis 5 times, and in fact, it does. Now, it looks like a few of the zeros are decimals, so the leftmost point looks like it's a decimal. It does look like it intersects the x-axis at 0, 0. The third 0 is between 1 and 2. Then it looks like it hits the x-axis at +3 and +4. So since some of these are whole numbers, I'm just going to use my table. So I'm going to use my table and see. Does it intersect at 0, 0? Yes, it does. So you have the option of starting your first synthetic, with any of these zeros. I'm going to actually go ahead. I'm nervous about using 0 because I don't want to accidentally multiply something and add it and put the wrong thing. So I'm going to go ahead and pick +3. So +3. You could have also used +4, but either one of those works. So set up your coefficients. Remember, if you're missing any of them, you want to fill them in. So I am, in fact, missing the constant term, so I'm going to go ahead and fill it in with a 0. Okay, go ahead and pause the video. Push play when you're ready and you're done with your synthetic. Okay, so this, remember I started with a 0 of 3, but I also noticed that 4 was a 0, so that's going to be the next one that I use. I started with a quintic, I took out 1 0, so now I'm left with a quartic. So now I'm going to do synthetic division for this quartic. So we've got quartic, cubic, quadratic, linear, constant. I'm going to do synthetic again. Okay. Feel free to push pause right now. Push play when you're ready. I need you guys to practice here. Okay, so this guy was a quartic, which means that this guy is a cubic. Okay, so this is 1x cubed minus, so that would be a squared, this would be a 2x, and now I need to solve it. So I can't use my graphing calculator to give me any of the other zeros. I have to use either quadratic formula or factoring. Now, this is a cubic, so it's not a quadratic quite yet, but if you notice, it has a GCF of x. So if I factor out that x, then I do have a quadratic. So I have x, and then parentheses x squared minus 2. Now, remember in the previous problem, we had a GCF of 4, but 4, when I set it equal to 0, doesn't make sense because it didn't have a variable. Here, you do want to set this one equal to 0 because it has a variable. So one of your answers is 0. And think back to your graph. 0 was a 0, right? 0, 0, the origin, your polynomial intersects it. Okay, and then we're going to solve this. I'm going to go ahead and use SADMAP because there's no linear term. Feel free to use quadratic formula by just filling in the b. So you can use a, b, and c. But that's not factorable. This is not a difference of squares. I'm going to go ahead and use SADMAP, which is inverse order of operations. So there's the other 0, and that's where those decimals came from. So if you take your calculator and you take the square root of 2, you get 1.41, which is pretty much between 1 and 2. So there's the 1.41. If you do negative root 2 on your calculator and change it to a decimal, you get negative 1.41, which is the leftmost. So remember that 2 of the zeros look like they were decimals. The rest were integers or whole numbers. Okay, so my complete list is in order. You can put the conjugates together. So you can put plus or minus root 2, then 0, 3, and 4. But if you're going to break it up, look at your graph. Negative root 2 would go first, then 0, then positive root 2, then 3, and then 4. Because remember, this guy was negative 1.41, blah, blah, blah. And this was what, positive 1.41, blah, blah, blah. As always, if you need extra help, feel free to send us a message on Remind, and we'll be happy to help you. Have a good day, guys.